any of these systems is, you're looking at years in order to show comparability if you're trying to move to a different system or to a different upgrade. So I think whatever mass spec style you've chosen, you're probably kind of stuck in that for a long time. So whether it's like a single quad or triple quad or top, so definitely going with care on what you're going to use to employ your man-based methods, because I think it's hard enough to go from a software up version of the same technique, but if we try to move techniques laterally, that's going to be really messy. So I think having security that whatever style or brand that they've come out with, that's going to kind of stay the course, definitely is critical.
Ideally, when we talk about methodologies, we want them to translate from very beginning of the product lifecycle all the way through the end, and then be useful for essentially for the lifetime that the product's produced, which could be a long time, right? So I think it's a challenge, because you're not gonna, any minor change to an instrumentation post regulatory approval is going to require some significant paperwork. So I would say a couple of things. Companies will have to have people with expertise to be able to maintain that instrumentation for some time, and or companies who want to get into that space in terms of analytics will have to think about supporting the hardware and software longer term than what a traditional life cycle of an instrument might be today.
The reproducibility, if we're talking about, like a percent of your main peak, sample to sample, like whenever you're comparing whatever, we can say like a post-translational modification. So from sample to sample, that kind of reproducibility is pretty good whenever you're doing like a nominal quantitation from the sample. So we do definitely have some issues with the data output side of things. So like your raw data might be fine, but finding a way to process it in a way that's really consistent and appropriate in all pieces can be tricky. I know there's been some discussions of updates in that kind of space with like, better retention time alignment, better normalization of the data. But one of the things we're considering is like a more standardized internal standard, as an example. Something pretty inert that we can use to sort of help mitigate the just day-to-day fluctuations that we see.
So if someone is using the low resolution platforms, I think the reproducibility, because you're using the MRM kind of assay, so these are like pretty reproducible. But when it comes to the high resolution platform, though the kind of systems what we have today as compared to the earlier instruments, these are much more robust. The kind of fluctuation, day-to-day fluctuation is not that high. But still sometimes, because MAM is something which you need to run for longer days for the high throughput analysis. So a typical batch, what I understand, is running from say 48 hours to 72 hours. So then how frequently you need to do the system calibration, and to the point Rachel mentioned that having a right internal standard there to maintain that calibration for that longer duration. So I think that is something still, because the environmental fluctuations cannot be controlled. So the instruments, if they are more robust to those, less sensitive to the temperature conditions, and I'm sure like latest ones are pretty much able to give that performance at least for 48 hours or 72 hours. But still, one requirement is to do that frequent calibration. So if those can be taken care of with the right set of maybe the system suitability criteria or in between QC samples, I think that is good enough. The other thing is if we see the future of MAM getting implemented in manufacturing, like for PAT and other inline and outline technologies, so I think that's where a smaller portfolio would help in having more number of mass specs. So I think that smaller footprint is the need, and I'm sure like most of the machine system manufacturers are already working on that part.
So first, the reproducibility of the method from one lab to another, from one equipment to another. Even during time, if you don't have an instrument that is highly reproducible, you may have issues when analyzing the same sample, for example, during stability studies. The lifetime of the method and the lifetime of the product is one of the challenges and one of the reasons people are still reluctant, I think, to use MS in QC, and that's really something that has to be addressed. Clearly, in order to use this kind of method, you need to have a system that is quite robust, that can be used over several years. So, for example, the first QTOF we had at Quality Assistance, we used it for more than 10 years, and it still passed its specifications after 10 years. So that's something that you need in order to use such a system for a QC method. System suitability is required when you run your MAM method in a QC environment. So clearly you have to define a standard that you can use each time you perform the analysis. So it can be in-house standard, it can be a commercial standard, it will depend on what you want to do exactly. It's something that has to be highly characterized and highly stable also in order to be used for the all around the lifetime of the method. This SST standard can be used to check the sensitivity of the system, but also to make sure that, for example, you can set some criteria on oxidized peptide, deamidated peptides, and so on, to make sure that you still get the same value all along your analysis, and make sure that your sample analysis is reliable. The main reason we chose our system was the reproducibility of the system, the robustness of the system. For MAM analysis, you don't need the best sensitivity you can get, you don't need the best resolution in terms of system performance. What you need is robustness. You will probably analyze a lot of samples, so the downtime of the system should be as minimal as possible. You should have a system that is robust, that can be used by many different people. You should have a system that will give you almost the same performance during the time, whoever uses it, and whatever samples you may run on your system. So if you have to clean your systems every day for several hours in order to get excellent performance, it's not a system that can be used for MAM studies. So that's the main parameters we took into account when we chose our system for MAM. And we also need a system that, when installed at different locations, so we are a CRO, so our customers will maybe use the same system. Other subcontractors will use the system. If the method has to be run at different locations, you need to have a great reproducibility between systems. You don't need the best resolution, the best sensitivity. That's not the main point.